Hello, and welcome to video 5 of Module 3, Percentiles. In this video, we'll discuss one way that you can see how an individual compares to the rest of the values within a dataset. A value is said to be in the pth percentile if it is greater than p% of the data. So, for example, if Ulysses performed better than 90% of the other students on his test, we would say that his score is in the 90th percentile. Sometimes, like in this instance with Ulysses, performing in the 90th percentile is a good thing. However, sometimes being in a large percentile is not so great. For example, if I were in the 90th percentile of people who are at risk for heart disease, that would not be a very good thing. That would mean that my risk for developing heart disease would be greater than 90% of the population. Now, we've secretly already been using percentiles. One of our measures of center was the value that was in the middle of our data set. It was greater than 50% of the other data values. Do you remember what measure of center that was? It was the median. The median is the value that's greater than 50% of the values in your data set. So the median is the 50th percentile. Next, we're going to talk about one method for finding percentiles in a data set. Before we do that, I'd like to point out that there are many different ways to determine a percentile, and they don't all agree. The reason that there may be some discrepancies among them is because some methods for determining percentile are really precise. They give you a better result, but they are more challenging to compute by hand. So, for example, Microsoft Excel has a program that will compute a percentile. Most graphing calculators can compute a percentile, and so on. The method that we will discuss in this video is relatively straightforward. It's a little bit simplistic, but it gives us a good estimate of a percentile value and isn't too hard to calculate. Let's see what those steps are going to look like. Before we discuss our steps, we want to make sure we know what our variables mean. So the p here is representing the percentile. So for example, if I'm looking for the 70th percentile, then p would be 70. The sample size is n, so n represents how many values are in our data set. So if I had 40 numbers in my data set, n would be 40. When we go to find a percentile, our first step is similar to the median. We want to make sure our values are in order from least to greatest. Our second step is to find p% of n. So for example, if I'm trying to find the 70th percentile in a data set of 40 values, then I would find 70% of 40 in step number 2. What step number 2 gives me is a location. It gives me a place in my list of data to look to find the value that is in that percentile. Step 3 is going to tell me how to use that answer, how to use that location. If my answer is a decimal value, then I'm going to round that value up to get the location of the percentile. So for example, if my p% of n is 4.2, I will round that up to 5. And what that tells me is that that percentile will be the 5th number in my list of values. If, however, our answer is a whole number when we find p% of n, then we will take the mean of that location and the location after that. In other words, if I find p% of n to be something like 9 exactly, then I'm going to go to the 9th number in my list and the 10th number in my list and find their mean. Now, the reason step 3 is here is kind of similar to when we found the median. Remember that if you had an odd number of numbers, then your median was taken from one value exactly in the middle of your data set. But if your number of numbers was even, you had to take the mean of the middle 2 numbers. So there's a similar thing happening here. In some instances, you're only going to need to take one number. In other instances, you're going to need to take the mean of 2 numbers. You're looking for a spot in between the two. Let's look at an example. Suppose the following temperatures in degrees Fahrenheit are collected one winter. Part A, what is n? Remember that n is the number of numbers. So I found n to be 20 for this data set. Part B. Let's find the 8th percentile. As we go through our process of finding the 8th percentile, let's make sure we number our steps for this example. So step 1 was to make sure that your values were in order from least to greatest. Unfortunately, it looks like this has already been done for us. Step 2 is to find p% of n. In this case, since we're looking for the 8th percentile, and there are 20 numbers, we need to figure out what is 8% of 20. Now, there are lots of different ways that you can figure out a percent. Personally, what I like to do is to turn the percent into a decimal and then multiply. So that's what I'm going to be doing, but you can use the method that you are most familiar with. In this case, that means turning 8% into 0.08 and then multiplying by 20. And when I carried out the multiplication, I got a value of 1.6. Since my answer was a decimal in step 2, for step 3, I'm going to need to round that up to the next whole number. So here that'll be a 2. And that 1.6 is telling me that my 8th percentile will be the second number in my list. So I'm going to start counting from the beginning, and I count 1, 2, and that means that second number, the 3, is going to be my 8th percentile. In other words, 3 is greater than 8% of the values. So the 8th percentile of this data set is 3 degrees Fahrenheit. Let's do a few more examples so we can feel more comfortable with this method. Example C. Let's find the 25th percentile. Now, because we already know that our numbers are in order from least to greatest, we can skip step 1 and move straight to step 2. Because we're looking for the 25th percentile, that means I need to find 25% of 20. We can do this by multiplying 0.25 by 20, and we end up with a 5. Now, for step 3, we have to look at our answer from step 2. In this case, our answer from step 2 was a whole number, so we have to treat this a little bit differently than we did in the last example. When you find a whole number, that means you're going to have to look at the value that's in that spot and the next one. So we are going to look for the 5th and the 6th numbers. So we count through our data, 1, 2, 3, 4, 5, and 6. So the 4 and the 5 are the 5th and 6th numbers in our data set. To find the percentile, we're going to have to find the halfway point between these two values. In other words, we're going to add 4 and 5 together and then divide by 2. And when we do this, we end up with a 4.5. This means that the 25th percentile is 4.5 degrees Fahrenheit. Let's do one more example with this data set. For example D, we've been asked to determine the 61st percentile. Again, step 1 is done because our values are still in order from least to greatest, so we can skip on to step 2, where we need to determine 61% of 20. This means I have to multiply 0.61 times 20, and that will give me a 12.2. In step 3, because my answer to step 2 was a decimal, I'm going to have to round it. However, remember the rounding rules are not round like usual. It's round up to the next whole number. So in this case, I will round 12.2 up to the next whole number, which is 13. I need to find the 13th number. Now, the reason that we have to do this rounding up is as follows. To find the 61st percentile, we need to ensure that we are greater than 61% of the values in our data set. Our location of 12.2 means that I have to be larger than the 12.2nd number. In this case, if I only looked at the 12th number, I would not be reaching that cutoff of 12.2, so I have to go to the next spot over. So let's count to the 13th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 8 is the 13th number in our list. This means that the 61st percentile will be 8 degrees Fahrenheit. Now, one of the things that I find particularly difficult about identifying percentiles is that we really have two numbers at play here. We have a location value and we have the percentile value. So it's important to remember that the number 8 here is not the 8th number in our data set, it's the 13th number. So you may want to practice identifying the location of certain values versus identifying the value of a number. Now, often in math, when you learn how to do something going in one direction, you also learn how to figure out how to undo that thing. So we can also find percentiles kind of going backwards. In other words, if I were to give you a number and I said, in what percentile is this number? We have a method to do that. In this case, we're going to use a formula where the percentile will be 100 times our location minus a half, all divided by n. Notice that this percentile formula uses the location of the value, not the value itself. So once again, before we can state our answer, we need to find the location of the value that we're looking at. When we use this process, if x is not an exact value in the dataset, you're going to go to the next value up. Also, you will always round your answer to the nearest whole number. Now, as we discussed before, there are a variety of methods that we could use to determine the percentile that a value is in. In this case, we've once again used a technique that's going to be fairly easy to calculate. However, this is not a perfect undoing of our previous method. In other words, if I were to enact our previous method, if I found the 25th percentile using the method we just did and got 4.5 degrees Fahrenheit as an answer, if I now went to undo that process using this formula, I might get a slightly different answer. Instead of the 25th percentile, I might get the 23rd or the 24th or the 26th. So the process will give us a close undoing, but not an exact one. So again, the reason this is happening is because these processes are fairly easy to do by hand, which means they can't be as supremely accurate as we may want them to be. So let's do a couple of examples using this method. Here we have the same temperatures as before, and before we can undo this percentile process, we once again need to identify our sample size. In this case, n is still going to be 20. For part B, we've been asked in which percentile is x equals 11 degrees Fahrenheit. Because it was on a previous screen, I'm just going to write down our formula so we don't lose track of it. Now, in order to use this formula, we need to know the location of x. In this case, x is 11. So I can't plug 11 into the formula. I need to figure out which spot in line is 11 sitting in. So first we're going to figure out, well, where is 11? Let's find it. So here it is. And now I have to count from the beginning to get its location. So we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 11 is the 15th number in this list. So 15 is the number that I get to plug into this formula. So we'll take 100 times 15 minus 0.5, and then we'll divide that by 20. Now, you may be wondering, why do I have to do this minus 0.5 business? How come I don't just take the 15? This is because 11 is not greater than itself. So that minus 0.5 is to give me a little bit of a wiggle room, a little bit of adjustment, so that I'm not including 11 when I count my percentile. You can think of this kind of like an error correction. When I carry out my operations, I'm going to do that subtracting first to get 14.5, and then I can multiply and divide, and that will give me an answer of 72.5. Now, in this process, we were told to always round to the nearest whole amount. This is different from our method of finding the value in a percentile. Remember, in that case, our rounding was always up to the next number. In this case, we're just going to round like usual. So since we have a number of 72.5, that 5 says this is going to go up to the 73rd percentile. So we would say that 11 is in the 73rd percentile. Let's do another example. In which percentile is x equals 25 degrees Fahrenheit? If I look at our data set, the value of 25 doesn't appear anywhere. If it was going to appear, it would have happened here between the 14 and the 27. When this happens, we're going to use the location of the next value up. This is because if 25 had been in our data set, it would be in the spot where 27 is. So in this case, we're going to use 20 for our location because the 25 would have been the 20th number in our list. So let's write down our formula, and we'll get 100 times 20 minus 0.5, all out of 20. Notice that we keep our denominator of 20 the same. We don't make it 21 because 25 was not an actual value in this data set. When I carry out the subtraction and the multiplication and division, I end up getting 97.5. So this means that 25 degrees Fahrenheit would be in the 98th percentile, because when I round 97.5 to the nearest whole amount, I end up with 98. Now, this is one instance where this method is a little bit iffy. Some other instances could be when you have repeated values. For example, if I were to ask you in which percentile is x equals 3, would I use 2 or 3 as the location? But for our purposes, I'm not going to ask you anything like that. Again, this is intended to be a fairly simple method, so we're going to try not to be super complicated. I hope you've enjoyed this video about percentiles. In our next video, we're going to be talking about something called a 5-number summary, which is going to incorporate some percentiles. If you would like to watch that video, you can click on the arrow to the right. If you'd like to review measures of dispersion for grouped data, you can click on the arrow to the left. As always, thanks for watching, and have a wonderful day.